Hello, students and friends. My name is Manoj Varma. I'm from Mumbai, India, and I'm back again with another video on analytical chemistry from the A levels. But this topic is also applicable to other international boards. And the topic for today is electrophoresis. So I have taken a question from the October-November 2018 paper, and the paper variant is 41 and the paper code is 97, subject code is 9701. So let's discuss this question and the answer with the explanation. So the question says that use the data booklet to draw the structure of the dipeptide val list. The peptide bond should be shown displayed, and you have to use the data booklet to get the structures of the two amino acids valine and lysine. So for that purpose I have taken the help of the data booklet. So this is the general formula of the amino acid, and R is the side chain, and the side chain in valine, VAL is the abbreviation, is this part, isopropyl group, and for lysine, the R group is this group. So if we attach this group in place of R, then we will get the structure of valine, and if we replace this R with this part, we will get the structure of lysine. So that's what I have done. This R is here, this group, isopropyl group, and therefore I get the structure of valine, and when I replace this by this group, I get the structure of lysine, and I'm supposed to draw the dipeptide. So you know that in the dipeptide there will be the CONH bond. So I have taken the structure in which I have taken this part, the valine part, and this NH2 part comes over here. This isopropyl group comes over here, and then this CO group comes here, and I have taken this NH2 group over here, and this group over here, and the COH group over here, and between the COH and the NH2, a water molecule is eliminated, giving the CONH linkage. So this is the formula of the dipeptide. The student should notice that at one end, one terminal, we should show the NH2 group, and at the other terminal we should show the COH group. Reason being that this can extend the chain and form many more peptide linkages. So the R groups you can show vertically upwards or downwards, and the NH2 and the COH group you should show at the left and the right corners, and CONH linkage is in the middle. This is how the dipeptide structure is drawn, and this is the answer from the mark scheme, which is same as this answer. Okay, let's go ahead and look at the next part of the question, which is a little bit more challenging. The isoelectric point is the pH at which an amino acid exists as a Zwitter ion. The isoelectric point of valine is 6.0 and of lysine is 9.8. A mixture of the dipeptide val-lys and its two constituent amino acids, valine and lysine, was analyzed by electrophoresis using a buffer at pH 6. Draw and label 3 spots on the diagram of the electrophoresis paper to indicate the likely position of each of these 3 species after electrophoresis. Explain your answer. So let's try to understand this question and the answer. The isoelectric point of valine is 6 and that of lysine is 9.8, and the buffer that we are using to analyze this mixture is having a pH of 6. So as you can see that this pH of buffer 6 is same as the isoelectric point of valine but lower than the isoelectric point of lysine. So let's see what will be the impact of this. See, the pH of buffer is 6 and the isoelectric point of valine is 6. So isoelectric point is the pH at which the amino acid is in the form of a zwitter ion. So since these two are identical, therefore valine will be in the form of the zwitter ion with no net charge. So it will not move towards any electrode during electrophoresis. Now, the pH of buffer is 6, whereas the isoelectric point of lysine is 9.8. So the pH of 6 is more acidic than the isoelectric point of lysine. It is more acidic. So if it is more acidic, then if you look at lysine, if it is more acidic, then this will accept a proton and change into NH3 plus. That means it will become protonated and it will develop a positive charge. So more acidic, therefore NH3 group will change to NH3 plus and therefore it will move to the negative electrode. Even the dipeptide will be protonated and therefore it will also move towards the negative electrode, but dipeptide has a greater mass than the single amino acid, so having a greater mass it will move more slowly in comparison to lysine. So this is the answer. So where will you have the spots? Obviously the amino acid valine will not move at all. As you can see the answer, the valine will not move. Lysine and the dipeptide will both move towards the negative electrode because both are positively charged. The dipeptide will move more slowly than the lysine, and therefore these are the three positions and the three spots of the mixture. Thanks a lot for watching, and I hope you understood the explanation and the answer. Please comment, like and share the video. Thanks a lot and meet you in the next video.